Hello everybody, my name is Ofus and this is episode 2 of Kerbal Space Program. In this episode we are going to try and get into orbit. And in order to get into orbit, I have downloaded a new mod in order to help me get into orbit. And I'll show you how that works right here. Let's go ahead and start with our little command pod. I'm going to go ahead and add all the essentials that I need. We've got our decoupler here and we've got our fuel. And that's going to be our basic rocket right here. So we already built this in our last episode, but in this episode I'm going to add a new fancy gadget, which is our mod. It's called Kerbal Engineer Redux, and basically what it does is it calculates all the math we need for our science in order to tell us what our rocket can do. Now this number right here is called delta V, and basically what delta V is change in velocity. You need a certain amount of change in velocity in order to get Kerbin, or get your spacecraft off the ground and to get into orbit. And this number is calculated by a very complicated calculation. It's basically the power of your engine and how heavy your rocket is goes into delta V. So if you have a heavier rocket, okay, let's see here. If I were to add, I don't know, like 5 of these, I would get less and less. I would be getting more delta V, but I would be getting less and less delta V because the rocket is getting heavier and heavier and heavier. Each tank would give me less delta V out of it. And you can see right here that my thrust to weight ratio is going down. What thrust to weight ratio is basically, can you get your craft off the ground? Is your craft too heavy? As long as it's over like 1.5, you're fine. If it's below 1, you're dead. That means you're not getting off the ground, period. You're just wasting fuel. So, in order to get off of Kerbin and get into orbit, I need a craft that has 47,000 units of delta V. Now, that shouldn't be very difficult. You see here we've got our new fuel engine, which steers better. This is L30, yeah, L45. This is the one I need. So I'm going to put that rocket there, and I took off my Kerbal Engineer when I deleted the other thing. So we're gonna add I'm gonna add the Kerbal thing on the front of the spacecraft, and there's a reason why. Because on the back of the spacecraft, I'm going to add our new science module. It's the Mystery Goo Containment Unit. Basically, this is a piece of goo. It is a new science experiment that we will be able to use in order to collect science in the air outside of crew reports and EVA reports. Now we've got this goo thing that reacts differently in different environments. So when I take it into space, it might freeze or expand or contract, and we're going to be able to learn valuable things in order to enhance life support systems and gain science in order to help us advance farther in the game. So we're going to move this up here and start adding our second stage, which is going to be not much different than that. It's going to be 2 more rockets like that, and we're going to add another engine down here. And you see that we still don't have enough. We've got about 3,600. I need about 1,000 more. See, and this one's even getting lower as far as thrust to weight ratio. So I'm going to need a really powerful thing to help this thing actually get off the ground, and that is why I bought our radial decouplers. So I'll show you how these work. These are going to let me attach things onto the side of my ship, and in this case it's going to be more rockets. So let's go ahead here and attach these here. It's actually better if I do this one at a time and then split it up, but I think I can do it just right here in front of you guys. So we're gonna add that right there, boom, and add rockets to it, and boom. So that gets me plenty of fuel. This first one's definitely gonna have enough to get me very far off the ground. The second part right here, thrust to weight ratio is a little bit lower than I would want. It's still going to work, but it's not really going to matter because there's not going to be as much air resistance high up in the air, which means that once you're in space, basically, thrust to weight ratio doesn't matter. Thrust to weight ratio is based on the weight of your craft and the gravity of the planet that you're launching from. So this rocket should be more than enough to get us off the ground and into the air. Let's make sure that I don't forget to add a parachute. And let's see if I got my staging right. I've got these 4 rockets here, and then I've got the decouplers, and I've got the center rocket, which I'm going to put in the same stage as the decouplers so that this will fire at the same time that these break away. And I'm going to do the same thing here, and I need to split up my decoupler and my parachute on the last stage, and we are good to go. I think it's time that we can start giving these spacecrafts a name. So this is going to be Kerbin Orbiter 1. I don't know if we're going to have other orbiters, but we'll find out. So let's go ahead and launch it. Now, Kerbal Engineer doesn't just give you cool things to help you build your craft, it also gives you very important statistical data on how your craft is doing as you're flying. So, see right here, I've got my distance and I've got my delta V. That is all I'm going to need in order to launch this mission. So I'm going to sit it up here at the top here. We can see Jebediah in the corner. I think he's ready to go. So we're going to go ahead and hit T, and we're going to go ahead and power up our throttle, and up we go! As we tear away very quickly, actually. We're going really fast. Now, if you want to get up into orbit, the first thing you need to gain is vertical speed. So you want to be going real high up really fast in order for you to start getting your head start into going into orbit. So we are going to sit up here until we hit about 5 kilometers is a good way to go. Let me view out on my craft here because that will cut down on the noise. So you want to go up to about 5 kilometers, and after that you want to start gaining horizontal speed. So I'm trying to steer my craft here, and it's sort of working, sort of not, because my craft is rotating. But I want to put it at about a 45-degree angle so that I can get us high up into the atmosphere. So as you can see here, no, I didn't mean to turn that off. Good. Okay, my stabilizer's back on. Let's hit the map. You can see here that I'm going really high, and my first stage has cut out. So we're going to have that drop away. Now my second stage is kicking in. And so this if you look at my nav ball here, this yellow thing here is telling you the exact direction that my craft is pointing. So the stabilizer is going to hold that position so that we can go to the map. We're hitting 38,000, 39,000. This is our Ofus up here. It is technically the lowest point in the orbit, but since we haven't made orbit yet, we're still suborbital. This is the highest point we are at off the ground. Now, I'm not really going to need to keep looking at the map here because I can see up here what my Ofus height is going to be. And my delta V is still going down right here, so that's telling you how much fuel, how much longer that engine's going to burn in seconds, and how much velocity change that I have left. Okay, so I've hit 100,000, so that's where I want to be. I've hit 100 kilometers, so that is a good orbital distance. So now what we need to do is start planning how we are going to get into orbit. Now, I can do this without maneuver nodes, but if you haven't played this game before, this is a good time for me to show you. So, maneuver nodes will help you plan where you need your craft to go. Now, I needed to get into orbit, so let's see here. That would give me 120, which is a little high for what I want. That's 102, so that's perfect. So this little orange line is where I want my craft to go. If we look at our little nodes here, this would be faster. If I drag this node, it would get me slower. If I drag the blue nodes, that would drag my orbit left or right. And if I did the purple nodes, that would drag my orbit up or down. There's complicated science terms that goes into that, but that's basically what we're going for. Now, this is telling me down here that I'm going to need 1,295 units of fuel in order to get into orbit. And if you see over here, I have plenty of that. I have the delta V I need in order to get into orbit. And it's telling me that my node is going to be in 1 minute and 11 seconds, so I need to work on getting my craft into the position that I need. Now, because I set a maneuver node here on my nav ball, this blue icon here is telling me where my ship needs to be pointed once I hit my maneuver node. So as long as I point where the thing tells me to, and burn as long as the thing tells me to, I will hit this orbit that will that is defined by this orange line. That is the point of maneuver nodes. Now you also want to burn your orbit a little bit early, because this maneuver node, the math that goes in here, is assuming that your change in velocity is instant. So you want to burn a little bit before the node, so that you're burning a little bit before and a little bit after. So I'm going to wait until about 15 seconds maybe before I hit the node, before I burn. So right about here is where I want to go. And you can see that my rocket is burning, and this stage is going to run out mid-burn, so I need to go back and focus on my ship here. And you can see that my periapsis height is raising quickly, and while my aopsis height is pretty much staying the same. That's about where I want to keep it. That stage is going to run out, and then this is going to push me into orbit very, 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 very quickly. And you can see my blue line is expanding here, as it will push me into orbit. And once I get into orbit, I will be able to do the science that I need. Okay, we're coming up, and I might have to kill the engine dead here, and boom! I kill the engine, and I've got 117.87. Let's push that a little bit longer. 93, 94, 97. That's about where I want the orbit to be. It doesn't come out perfectly, but it is going to be good enough for what I need it to do. We are officially in orbit. Now, the best way to look at an orbit is basically that you're constantly falling. But you are traveling so fast that you don't hit the ground. Kerbin's gravity is keeping you in a circular orbit around the planet. So you are falling towards the ground, but you're traveling so fast that by the time you fall, you're already past the planet. So that's more or less how an orbit works. So that now that we are in a safe orbit, I can go ahead and get some science taken care of. First thing I'm going to do is my crew report, which we've seen us do before. So let's take care of that. It seems like we are very much in space right now. The sky seems to be mostly below us. We're going to keep that data. And we're going to send Jebediah Kerman out for a EVA report. You've recorded the observations about the situation. Now, if I wanted to, which I will, I can sit here and pull away from my vessel, you know, kind of like this. And I'm not going to fall back to Kerbin. Well, I could if I'm not careful, but basically the reason why this craft looks stationary while I'm floating in space is because I am traveling the exact same speed as my spacecraft right here. So for all intents and purposes, I am weightless, and I can fly around my craft if I don't, you know, kill myself. Why am I not going up? Okay, shift makes me go up and control makes me go down. Yeah, so that's going to be very helpful for us when we need to go out and do EVA missions for our rockets, for our rocket mission. So let's go ahead and grab this and get back in the craft. And let's go ahead and get the science goo, the mystery goo. Let's see what that says. Oh, 10 science right there. The goo seems to have clumped up into a sphere. It also appears to have become brittle. Yeah, so that's pretty much it. We are sitting here in an orbit. We've got all the science experiments that we need. And now it is time for us to float back down to the planet. But I'm going to wait a little bit. And the reason why I'm waiting is because I want to land on land. And I should probably want to land on the daytime side so you guys can actually see what I'm doing. I am going to deorbit and go back onto Kerbin's surface so that we can recover the vessel, but I want to do it on land so that I can get more science from a surface sample. Is there any land that is available for me to land on the daytime side? Yes, there is. So I'm going to try and drop it right there in that desert is what I'm going for. So in order for me to get out of orbit, I need to point my craft in the opposite direction that I'm flying and literally slow myself down. So I'm going to go ahead and take care of that, and if you watch, my orbit is decreasing to the point where I'm going to fall back into Kerbin's atmosphere right here. And I'm not sure how to do it precisely so that I'll land on land, but I think I'll do it right about there. And I think Kerbin's atmosphere will be enough to slow me the rest of the way. And crap, I just realized that Oh, no, I wouldn't have to do that. Okay, here is the problem. I did not plan my spaceship very well. If I were to use my decoupler right there, I would basically be throwing away all the important data that's in here. But luckily for me, I can perform an EVA mission. That's what we have them here for. So I am going to physically take Jebediah Kerman out of the spacecraft and recover the data and bring it into the capsule so that he can... No, I don't want to do that. So that we can just send this command pod back to Kerbin. So let's go ahead. We're going to turn on our rocket pack. We're going to back up here. If you are not very careful, because I only have a certain amount of fuel here, if you are not careful, you will run out of fuel and end up stranding this guy in space. And yes, you could recover him, but it's very difficult, and I don't want to go there right now. So let's see if we can do this as carefully and as painlessly as possible. So we got that. Collect data. Remove data. Yes. Alright. So we have the data from the pod. And now we are going to go back to the command pod and go back inside. Where's the front door? Okay, there's the door. So we're going to come up. I'm not the best at this. Alright, so he's grabbed. He's on board. And now we can start heading back down to Kerbin. So let's spin around here. And boom! Send this thing flying away. Because we are in a suborbital trajectory, that will crash down into Kerbin's atmosphere eventually and land on the ground. Now for us, we are just going to coast in, and the atmosphere will stop us enough so that we can land on land. It's not going to land all the way back here on the ocean like it says it will. So let's go ahead and start a physics time warp. Let's see here. Let's make sure I've got myself pointed in the right direction. Boom. Okay, so we are going to go super speed. Whee! Okay, maybe I did overshoot that just a little. I think I will overshoot the water. We'll see here. But let me get my craft back in the orientation it needs to be and start physics warping. And I'm starting to wig out of control here. Yeah, that's not exactly good, but I think we'll be fine. I guess I should have taken a much steeper orbit in. But yeah, I'm definitely going to overshoot that land and probably land maybe over here. We're going to have to see. I have no idea where my craft is going to land right now because I didn't plan that out too well. Double time's working pretty well. Triple time's working pretty well. If I go to quadruple, it's probably going to throw my craft out. But I'm going to go ahead and deploy my chute and prepare for the eventuality of my landing. Yeah, you really shouldn't turn when you're in super speed, because now I cannot control my vessel. This is bad. This is very bad. I do not have any control over the vessel right now. And I know why, because my electric charge has run out. I've had my stabilizer on the whole time, and when you don't have an engine, the engine works like an alternator. So I can keep my electric charge up if I keep my engine going, but because I discarded my engine, the battery power just completely ran out. So I'm not entirely screwed. But, I mean, until this parachute deploys, I'm just going to be flopping around here. I am a rock. And if you see right here, that little divot is the rocket that I launched earlier. Can we view in from there? No, it's too far away. So now we are re-entering. We have no orientation control. And if this was real life, this craft would be burning up in space right now. But it's not real life, so we will just watch Jebediah Kerman calmly fly. He's not scared at all. He's just got to fix his helmet, and he'll be just fine. Our G-forces are picking up here. Oh, this is scary. It's just wobbling all over the place. We are going to get a lot of valuable science here. Okay, so my chute has deployed, and that should be enough to stabilize my vessel at least a little bit. Let's go ahead and physics warp here. Woo! There we go. Well, if we don't land on land, we should be close enough that we are. The parachute is slowing us down, but so is the air. The thick air around us is slowing it down, and it looks like I will land on land. So I will be able to get a soil sample and maximize the science that we're going to get out of this mission. And I can take that science, and I think I will have enough in order to land on the moon. We will have to see what we end up getting out of the science for this mission. Getting on the moon is a pretty complicated ordeal. You have to do a lot of planning, and you need about, I want to say, 7,000 meters of delta V in order to get it done completely. Okay, so I have touched down safely. So I'm going to make an EVA. I don't think I can do multiple crew and EVA reports. Come on, walk away. Let go. Okay, so he's going to step out, and he's going to take a surface sample. Lots of sand and rocks here. You're thankful that you've been in a climate-controlled environment because it sure looks hot out there. The sand is dry and loose, and it looks like it's going to take some effort to clean your gear afterwards. We're going to get 9 science out of that. Each planet, well, some planets have different biomes so that you can repeat these experiments over and over again and still get the full amount of science for the work that you're doing. But that's only right now, I think, on Kerbin and the moons. They haven't added them to the other planets yet. So let's go ahead and recover this vessel. I know we ended up getting a lot of science because we get bonuses for, number 1, being in orbit when we do the science, and number 2, recovering a vessel that's been in orbit. And the mystery goo got us 10 science here, so we got 42 science out of that. We're up to 44 science total. Let's go over to the research and development screen. If I do want to go, let's see what else we have here first. We've got advanced rockets, which will give us side-mounted rocket boosters. We've got this one, which will give us more advanced side decouplers, struts, which will be very helpful for constructing a stable rocket. Those are worth 45 science. That's a lot. Or we could get into remote parts, but I think I'm going to go ahead and research this one right here, because that is the minimum that you need in order to land on the moon. I think I can build that one, but I think I might want to do one more mission in order to get the science that I need in order to get struts and stability enhancers, basically things that hold my rocket in place when I launch it. But that is going to be a mission for our next episode. Until then, my name is Ofus. Keep your feet on the ground!